This is Syntax Lee from Physics 2212, and this is Lab Report 2. The purpose of this lab is to design a computational model for a charge tape as a linear charge. There are three fundamental principles that I use. The first one is gravitational force, which is F equals ma. In this case, acceleration is considered to be gravity. And we got the Coulomb's law, which is F equals, in this case, F is electrical force, equals Coulomb's constant times the charges of two point charges divided by the distance between these 2 point charges square value. And we use the law of equilibrium to calculate that the gravitational force is equal to the electrical force on a single charge tape. And the results I got from lab 2 is that the charge of tape calculated in a linear point charge is 2.10756 e to the minus 8 coulombs. I assumed that each U-tape had about the same amount of charge evenly distributed on the length of the tape, and I excluded air resistance in the calculations. I predicted that the magnitude of the electrical force and the gravitational force would be equal since the charge tape is floating, and I calculated the charge on tape considering as a linear point charge to be 2.10756 e to the minus 8 coulombs. So my computational model looks like this. The first portion of the code includes the physical constants like the Coulomb's constant and gravity value. And the second portion includes the observation results I got from lab 1, which includes the tape width, length, mass, and the distance that repelled which I observed when these two tapes repelled each other. And this code of line is the point charge, which I got from lab 1. And this Q value, which I'll be using for this whole code, is the charge got from the tape when I consider it as a linear charge. And this function called E field calculates the electrical field, and this is the function I got from lab 1. And this given function called line charge displays numerous point charges that display as a line, which results to a linear charge. And these top tape and bottom tape variables use these return values of the line charge function. And as you can see, the top tape will be displayed in red and the bottom tape will be displayed in blue. And this portion of the code calculates the electrical force on the charge tape when we consider it as a linear charge. So if you can see in this particular line of code, we calculate the electrical force on the top due to the bottom's tape by multiplying the top tape's charge by the electrical field of the bottom tape. And we create a big arrow. We create multiple arrows of these point charges on the line of point charges. And as you can see, we will make this summation of numerous point charges into a single white arrow by using this line of code. And the gravitational force will be displayed by using this line of code, FG arrow, which will be colored in yellow. So if you run this program, we get this image of an arrow pointing upwards, which represents the summation of all these green arrows, which these green arrows represent a single point charge of these red point charges, which result into a single line, which we calculated as a linear charge. And this red line will be the upper tape, and this blue line will be the bottom tape. And this yellow arrow pointing downwards is the gravitational force. So as you can see, these arrows are very similar in size due to the equilibrium law. And as you can see, the electrical force and the gravitational force is similar in value, but not exact since we had some errors. So if I introduce these errors, the first error is that there could be external physical conditions that were excluded in lab 1, such as humidity, friction, and temperature. And we also got inaccurate measurement in lab 1 due to human error as well. I also used an assumption that all charges were evenly distributed along the tape, which could also result to an error that I got that the gravitational force's magnitude and the electrical force's magnitude was different. But in the real world, it wouldn't be since the charge tape is floating. For the first what-if questions, for the point charge, I got 1.4 e to the minus 8 coulombs, and the linear charge, I got 2.10756. e to the negative 8 coulombs, which is larger in magnitude than we calculated for a point charge. These estimates differ because the line charge model splits into numerous charge points, which results into a more accurate value. This is more accurate, which is closer to the real model, since a charge tape isn't a single charge point, but more likely a line of point charges. Thank you.